Jimmy Akin's Mysterious World is brought to you by the Star Quest Production Network and is made possible by our many generous patrons. If you'd like to support the podcast, please visit sqpn.com/give. You're listening to episode 88 of Jimmy Akin's Mysterious World, where we look at mysteries from the twin perspectives of faith and reason. In this episode, we're talking about the Nemesis Death Star theory. I'm Dom Bettinelli, and joining me today is Jimmy Akin. Hi, Jimmy.
Howdy, Dom.
Until a few years ago, everybody knew what our solar system contained. Some comets, some asteroids, 9 planets, and a star. But then in 2006, the members of the International Astronomical Union, who were present at a particular meeting, decided to demote Pluto from the status of a full planet, meaning there now were only 8. In recent years, some have proposed that the solar system contains another large planet, which the Pluto killers call Planet 9. But maybe the solar system contains something even more dramatic. In the 1980s, evidence began to emerge that our solar system may contain more than one star, and the second star, named Nemesis, may be responsible for the destruction of countless life forms on Earth, earning it the nickname the Death Star. Does our solar system contain more than one star? Is Nemesis real? Is it a Death Star that periodically causes the mass extinction of life on Earth? Is it a moon?
That's no moon.
And that's what we'll be talking about on this episode of Jimmy Akin's Mysterious World. Okay, Jimmy, so let's begin by establishing our terminology. How will we be using terms like planetoid, planet, star, and so forth?
I'm not a member of the International Astronomical Union, and I have severe criticisms of some of the definitions that have been proposed by some of the members of that body. The way I see it, we should classify objects primarily based on their nature rather than the environment they're found in. For practical purposes, this means classifying objects based on their mass and density, not what neighbors they have. And as objects gain in mass, their nature changes. Some objects in space are so small that they don't have enough mass to pull them into round shapes. So these objects are small and lumpy. They're too small to be called planets, and so we call them planetoids. A lot of asteroids, but not all, fall into this category. There are other objects, though, that are massive enough that their gravity will pull them into a round shape, like the planets in the solar system, and so they're naturally called planets. Some objects are so massive that they start crushing elements together in the process of nuclear fusion, so they glow, and this makes them the luminous objects that we call stars. And some stars are so massive that when they die, they collapse into very dense objects that don't emit light, and in fact trap light so it can't escape. And these are objects we call black holes. So as far as I'm concerned, there are 4 basic classes of objects: planetoids, which are objects in space too small to be rounded by gravity; planets, which are large enough to be rounded by gravity but not large enough to glow; stars, which are large enough to glow and that still emit light; and then black holes, which are incredibly dense and actively trap light.
Are there other possible classifications?
Sure. As with anything in nature, there are, for example, boundary cases. Some objects may be massive enough that they're almost round, but not quite. And if you want to come up with a special term for those, I don't have a problem with it. Similarly, some objects may be so big that they can almost glow, but not in the way normal stars do. And you can come up with a special term for those too. In fact, they already have a name. Those objects are called brown dwarfs because they don't produce light the way white dwarfs, which are a kind of star, do. So you can add new terms to describe boundary objects, but these terms should be based on the nature of the object, not the environment the object is found in.
So why do you have a problem with the definitions that are currently used by the International Astronomical Union?
Because they're not just based on the nature of the object, they're based on what it's near. According to the current IAU definition, for something to be a planet, it must have 3 characteristics. First, it must be in orbit around the sun. Second, it must be massive enough to assume a round shape. And then third, it must have cleared the neighborhood around its orbit by either absorbing or ejecting other bodies. So it's alone in its orbital neighborhood. The only one of those criteria that is based on the nature of the object is the second, which says it needs to be massive enough to be round.
What's wrong with the other two criteria?
Well, there's a big problem with the third criterion, that the object must have cleared its orbit. I mean, what does that even mean? If there's even one other object in its orbit, has it been cleared? What if the object has one or more moons that go around it? You know, it hasn't emptied its orbit if it's got moons. What about if there are a few objects in its orbital path? I mean, how many do you need before you don't call it a planet anymore? I mean, for example, you look at planets that are considered established planets in our own solar system. You know, what if they have a few tiny objects, little asteroids or rocks or dust, you know, little particles of dust even, that are still in their orbit? Those things can actually clump together at what are known as Lagrange points ahead of and behind the planet in its orbit. Jupiter, for example, has more than 1 million, they're called Trojan objects, in these Lagrange points before and behind Jupiter in its orbit. So does that mean Jupiter, the biggest planet, isn't a planet because it's got Trojan objects? And then what about earlier stages in the solar system's development, when there were even more objects in and around their orbits, but the planet's nature was still the same as it is now? You couldn't even establish when it got cleared and thus when something became a planet. And we can't possibly, given our lack of faster than light travel and our current generation and any foreseeable generation of telescopes, we can't possibly know whether objects in other solar systems have cleared their orbital paths. So this whole criterion is just unworkable. And the first criterion is absurd, that it has to go around the sun. Believe it or not, according to the IAU, that means it has to go around our sun. According to the IAU members who support the current definition, there are no planets in other solar systems. Any such bodies would be classified as exoplanets, not planets. And that's completely ridiculous. There is no reason why bodies that circle around other suns should be denied the title planets. They're planets too, but since we can't know whether they've cleared their orbits according to some arbitrary standard, we need to recognize them as planets based on their nature, not what else may be near them. And in fact, I would include stars in that. You don't need to be going around a star to be a planet. You could be a rogue planet floating between solar systems.
Are there members of the International Astronomical Union who agree with you?
Absolutely. In fact, some of the planetary scientists who were members of the IAU were very unhappy with the new definition. They felt that it was passed in a rushed fashion at a meeting that only a small portion of the IAU membership was at and able to vote. Some are also mad because they don't think that a lot of the members of the IAU are astronomers who study stars rather than planetary scientists who study planets. And they felt like those guys really shouldn't have as much of a say in what counts as a planet if their field is stars. You know,
Right.
It's kind of like voting on stuff that they're not the experts in. But one day, I'm confident reality will reassert itself and the definitions based on the nature of the objects rather than their locations will prevail. And at that point, people will realize we have dozens of planets in our solar system. And in fact, our moon is a planet and we are living in a twin planet subsystem.
Interesting. That could be a longer conversation for another time. So now that we've talked about the definitions for different kinds of bodies in space, including stars, why would anyone think that our solar system would contain more than one star?
One reason is that astronomers have historically argued that most star systems in the galaxy have at least one companion star. So if most stars do, you would expect our solar system to have more than one star. Here's a quotation from an article on space.com about multi-star systems.
Conventional wisdom on double star systems, called binaries, goes as far back as the late 1700s. More sophisticated observations made in the 20th century seem to confirm the numerical dominance of pairs. Stellar surveys found that more than half of all sun-like stars were part of multiple systems. For more massive stars, like O and B-type stars, the number was estimated to be as high as 80%. A few stars, like the North Star Polaris, have 2 or more companions. Quote, if you go out and look at all the visible stars in the night sky and ask, how many of those are binary, the answer is most of them, end quote, said study author Charles Latta of the Harvard-Smithsonian Center for Astrophysics.
But there is a catch. More recent studies have indicated that this isn't the case for low-mass stars like red dwarfs. The Space.com article continues.
Scientists estimate that red dwarfs make up 85% of the stars in our galaxy. These stars are about 1/5 as massive as the Sun and up to 50 times fainter. Red dwarfs are so dim that it's only been in the past decade or so that technology has improved to the point where astronomers can study them in detail. And they found that only about 25% of red dwarfs have stellar companions. Latta concludes that upwards of 2/3 of all star systems in the galaxy are single red dwarf stars. His finding, announced today, was detailed in a recent online edition of Astrophysical Journal Letters.
So you might argue that since it turns out that most stars are singletons, that our sun should be a singleton too. But that argument would be wrong. The reason is that our sun is not a red dwarf. It belongs to the category of larger, brighter stars that typically do have companions. For example, the Space.com article notes,
the skew towards singleness only applies to red dwarfs, however. It's still true that more than half of the brighter, more massive stars in the galaxy have companions.
So, based on the type of star our sun is, you would expect it to have a companion.
That's an argument from probability, but there's still a good percentage of sun-like stars that don't have companions. Is there any concrete evidence that our sun isn't a singleton?
There is, and to understand it, we need to talk about one of the rarest elements in the Earth's crust, iridium. Iridium is element number 77, which means it's 1 proton lighter than platinum, which is element 78, and 2 protons lighter than gold, which is element 79. Iridium was discovered in 1803, and it's a silvery metal that looks a lot like platinum. It's also really dense and has a high melting point, which makes it difficult to work. But those properties make it an ideal substance to build crucibles out of, since you want crucibles to be hard and difficult to melt. Consequently, it's used to make crucibles for the electronics industry so that manufacturers can grow high-quality crystals in them. It's also used to make spark plugs. And in the 20th century, iridium was used to make the quill tips for fountain pens, because being very hard, you could make a nice, strong fountain tip pen out of it, and it wouldn't wear down the way other softer materials would. Now, in the 21st century, doctors are experimenting with iridium as a way to invade and kill cancer cells. So it may have medical applications in our near future. And even though it's rare in the Earth's crust, we think there's a lot more of it on the planet than we've discovered, but it's hidden from us because it binds with iron. And most of the iron on Earth has sunk down into the Earth's iron core. It did that when the planet was forming, and so it took the iridium with us. Most of the iridium on Earth took a speediest way down to the planet core.
To quote Boss Nass from Phantom Menace. Very nice.
Yeah. Well, we're doing Star Wars references anyway, so
that's
why
right.
not? But its iron binding properties also mean that it's common in iron-rich meteorites, and this helped give us a big clue about the Earth's history. Here's a passage from Sam Keene's excellent book on the periodic table of elements, The Disappearing Spoon.
In 1977, a father-son physicist-geologist team, Luis and Walter Alvarez, were studying limestone deposits in Italy from about the time the dinosaurs died out. The layers of limestone looked uniform, but a fine, unaccountable layer of red clay dusted the deposits from around the date of extinction 65 million years ago. Strangely, too, the clay contains 600 times the normal level of the element iridium. Iridium is a siderophile, or iron-loving element, and as a result, most of it is tied up in the Earth's molten iron core. The only common source of iridium is iron-rich meteors, asteroids, and comets, which got the Alvarezes thinking. Bodies like the moon bear crater scars from ancient bombardments, and there's no reason to think the Earth escapes such bombardments. If a huge something the size of a metropolis struck the Earth 65 million years ago, it would have sent up a pigpen-esque layer of iridium-rich dust worldwide. This cloud would have blotted out the sun and choked off plant life, which, all in all, seemed a tidy explanation for why not just dinosaurs, but 75% of all species and 99% of all living beings died out around that time. It took a lot of work to convince some scientists, but the Alvarezes soon determined that the iridium layer extended around the world, and they ruled out the competing possibility that the dust deposits had come from a nearby supernova. When other geologists, working for an oil company, discovered a crater more than 100 miles wide, 12 miles deep, and 65 million years old on the Yucatan Peninsula in Mexico, the asteroid iridium extinction theory seemed proved.
So iridium provided a big clue about why the dinosaurs died, but I should point out that it may not have been just a single iron-rich asteroid that killed them. Many scientists think that there were big volcanic eruptions that were also taking place in India even before the asteroid hit, and that these volcanoes also helped cause the extinction. We'll be discussing the theories about why the dinosaurs died in a future episode. It's more open than the question is considered more open these days than it used to be. But it does look like an iridium-rich asteroid was part of the story. But the 65 million year old iridium layer wasn't the only one that scientists found. They found other layers. And the freaky thing was it looked like the layers occurred every 26 million years, regularly. Back to the disappearing spoon.
In 1984, some paleontologists began arguing that the dinosaur die-off was part of a larger pattern. Every 26 million years or so, the Earth seems to have undergone mass extinctions. Was it just a coincidence that an asteroid fell when the dinosaurs were due? Geologists have also begun unearthing other thin layers of iridium-rich clay, which seem to coincide geologically with other extinctions. Following the Alvarez's lead, a few people concluded that asteroids or comets had caused all the major wipeouts in the Earth's history. Luis Alvarez, the father in the father-son team, found this idea dubious, especially since no one could explain the most important and most radically implausible part of the theory, the cause of the consistency.
But Alvarez changed his mind, and what did it was another element, rhenium. Rhenium is element number 75, so it's 2 protons lighter than iridium. It was discovered, and this is a really ironic story, it was discovered in 1908 by the Japanese scientist Masataka Ogawa, and he named it nipponium after his home country, Japan, which is Nippon or Nihon in Japanese. But he made a tragic mistake. Instead of realizing that he discovered element 75, he thought he had discovered element 43. And scientists quickly showed that it wasn't element 43, so he didn't get to name it. After all, that's why nipponium is not on the periodic table. By the way, element 43, there's an interesting story there. It was really hard to discover, and there were multiple people who thought they found it and then turned out to be wrong. So Ogawa was just one of them. Bunches of people made this mistake. The reason it is so hard to find is that it's radioactive and it has a fairly short half-life of only 4 million years. And that means that over the 4 billion year history of the Earth, all of its element 43 has decayed into other stuff. So there's basically no 43 to find. You have to make it. And it was finally made and discovered for reals this time in 1937, and it was named technetium because you have to make it by technology.
Right.
So technicians make technetium. But back to rhenium. After Ogawa's failure to correctly identify the rhenium he had, element 75 was then rediscovered in 1928 by a group of German scientists who named it after Germany's Rhine River. So that's why they have the Rhine in Germany, so this is rhenium. It's a silvery white metal, and it has a really high melting point. Because of its high melting point, it's used to make parts for jet engines. It's also used in the process of making lead-free high-octane gasoline. And like iridium, it's really rare in the Earth's crust. Now, here's where rhenium entered Luis Alvarez's thought process. Remember, he's the guy who found the dinosaur-killing layer of the asteroid dust with iridium. Well, rhenium also comes into the picture. Back to the disappearing spoon.
As Alvarez's colleague Richard Muller recalled in the book Nemesis, Alvarez burst into Muller's office one day in the 1980s waving a quote-unquote ridiculous and speculative paper on periodic extinctions that he was supposed to peer review. Alvarez already appeared to be in a froth, but Muller decided to goad Alvarez anyway. The two began arguing like spouses, complete with quivering lips. The crux of the matter, as Muller summarized it, was this. In the vastness of space, even the Earth is a very small target. An asteroid passing close to the sun has only slightly better than 1 chance in a billion of hitting our planet. The impacts that do occur should be randomly spaced, not evenly strung out in time. What could make them hit on a regular schedule? Even though he had no clue, Muller defended the possibility that something could cause periodic bombardments. Finally, Alvarez had had enough with conjectures and called Muller out, demanding to know what that something was. Muller, in what he described as an adrenaline-fueled moment of improvised genius, reached down and blurted out that maybe the sun had a roaming companion star around which the Earth circled too slowly for us to notice. And whose gravity yanked asteroids to the Earth as it approached us? Take that!
Later on, the idea that the sun has a companion star that caused extinctions led to that star being named Nemesis, after the Greek goddess of retribution who punishes people with hubris. In fact, before we go further, let's take a moment to look at how the name Nemesis came up. In the early 1980s, Richard Muller, the guy who had the argument with Alvarez, published an article on the new idea with 2 other scientists, Mark Davis and Piet Hutt. Richard Muller is an important guy because he would go on to become the principal scientist advocating the Nemesis hypothesis. So remember him. In 1985, Muller wrote an article for the New York Times Magazine where he discussed this, and he said,
I somewhat playfully added a footnote to the paper suggesting that if the star is found, it might be given one of the following names. Nemesis, after the Greek goddess who relentlessly persecutes the excessively rich, proud, and powerful, for example, the dinosaurs, or Kali, the Black, after the Hindu goddess who is the destroyer of men and animals, yet who is infinitely generous and kind to those she loves, for example, the mammals. Or Indra, the Vedic god of storms and war, who uses a thunderbolt, comet, to slay a serpent, dinosaur, thereby releasing life-giving waters from the mountains. Or George, after the saint who slew the dragon. Finally, I added the sentence, we worry that if the companion is not found, this paper will be our nemesis. I hoped the tongue-in-cheek humor of the footnote would prevent anyone from getting angry over the thought of naming something which had not yet been found. To my surprise and delight, my co-authors, Mark Davis and Piet Hutt, did not veto the footnote. They liked it. Somewhat to my annoyance, and without my permission, an editor of Nature edited out all of the suggested names except the first. The theory soon became known as the Nemesis hypothesis.
So that's how the theory and the hypothetical star got its name. And it's too bad the editor edited out those others because, Indra and Kali would both also be good names for a planet, but so would George.
I like George.
We're going to go to planet George now. Anyway, back to Alvarez. After his conversation with Muller, Alvarez realized there might be an explanation for why it looked like asteroid and comet-based extinctions were occurring every 26 million years, and that led him to think about rhenium. Remember how in episode 80 on alien implants, we talked about how every solar system has its own characteristic ratio of isotopes. An isotope is a variant of an element that has a different number of neutrons. So that's why here on Earth we have loads of uranium-238, but very little uranium-235. By measuring those ratios, you could tell whether the material in an alien implant looks like it came from our solar system or a different one that had a different ratio of isotopes. Well, you can do the same thing with material from asteroids, and that's what got to Alvarez. In The Disappearing Spoon, Sam Keene explains.
Remember that all solar systems have a signature, a unique ratio of isotopes. Traces of rhenium had been found blended in the layers of iridium clay, and based on the ratio of two types of rhenium, one radioactive, one not, Alvarez knew that any purported asteroids of doom had to have come from our home solar system, since the ratio was the same as on Earth. If Nemesis really did swing on by every 26 million years and sling space rocks at us, those rocks would also have the same ratio of rhenium. Best of all, Nemesis could explain why the dinosaurs died out so slowly. The Mexican crater might have been only the biggest blow in a pummeling that lasted many thousands of years, as long as Nemesis was in the neighborhood. It might not have been one massive wound, but thousands or millions of small stings that ended the famous age of the terrible lizards.
So it might not have been just one asteroid that ended the dinosaurs, but a whole shower of comets and asteroids that Nemesis sent charging our way 65 million years ago. But not everybody is convinced that the Nemesis hypothesis is right, and there are alternative theories.
Before we get to those theories, I'd like to take a moment to thank our patrons who make this show possible. And this week we're thanking Jorge F., Tim D., Sean F., John C., and Patrick. Their generous donations at sqpn.com/give make it possible for us to continue Jimmy Akin's Mysterious World and all the shows at StarQuest. You can join them by visiting sqpn.com/give. So, Jimmy, what theories are there about the Nemesis hypothesis?
They fall into three general classes. The first one is that the whole basis for the theory is wrong. There is no pattern of regularly recurring mass extinctions. The second is that some version of the Nemesis theory is true. The sun does have a distantly orbiting companion of some kind. And then there's a third argument, or third theory, which is that there are regularly recurring mass extinctions, but they aren't due to the sun having a companion on a distant orbit.
Let's start with the faith perspective. What can we say about the Nemesis hypothesis from the faith perspective?
Oh, from one perspective, there wouldn't seem to be a lot to say about it. I mean, Genesis says that God created the heavens and the earth, and it goes on to say that he made two great lights, the greater light to rule the day and the lesser light to rule the night, and he made the stars also. So that would include, Nemesis, if it's there. As we discussed last week in episode 87 on the Nephilim, the author of Genesis avoids the names of the sun and the moon, since these were the names of the Canaanite sun god and moon god. He doesn't want people thinking that the true God created the sun god and the moon god. So the message is they're just lights. Don't worship them. But while the Genesis text accurately describes what we see from an earthbound perspective, there is a great light that rules the day and a lesser light that rules the night. It also mentions that God made the stars, and there could be a nearby star that is too dim for us to see, and that could be Nemesis. But Richard Muller does point out one aspect of the Nemesis theory that does relate to the faith perspective. While the church doesn't teach the theory of evolution as a matter of doctrine, because it's a matter of science rather than theology, it does acknowledge that God could use evolution in producing the living creatures we find on Earth, including the human body. And scientific evidence strongly supports that. Well, here's where Nemesis comes in. In his 1985 New York Times Magazine article, Richard Muller wrote,
"If our theory is right, the consequences for evolution are staggering. Classical Darwinian evolution has species competing against species. But now we hypothesize that this is the case only during the relatively benign periods between comet storms. Every 26 million to 30 million years, the Earth is subjected to a trauma that the otherwise successful species can't anticipate or prepare for. New ecological niches are opened, allowing previously suppressed species to gain a foothold. Had it not been for the large comet that hit 65 million years ago, mammals might never have wrested the Earth from the dinosaurs. At the time they vanished, the dinosaurs were more intelligent than the mammals, and they might have stayed ahead. Highly intelligent creatures might still have evolved, but with very reptilian features."
So if the Nemesis theory is right, Nemesis may have been part of God's plan in guiding the development of living creatures on Earth, including the development of humans.
So, what can we say about the Nemesis hypothesis from the reason perspective? What about the claim that the whole basis of the theory is wrong and there's no regularly recurring cycle of mass extinctions?
If this claim were true, then it would undercut the Nemesis hypothesis in one fell swoop. A no recurring cycle of extinctions equals no companion star flinging comets or asteroids toward us every so often. And there have been people who have argued this. One of them is a British scientist named Corin Baylor-Jones. In recent years, he's done an analysis of impact craters on Earth. But this is a tricky business because impact craters on Earth degrade over time due to weathering, seismic activity, continental drift, and so forth. Based on his survey, he concluded that the surviving craters don't support the idea that major impacts are occurring on a regular basis, but he was limited to just the craters that survive. Other scientists have reached the opposite conclusion. For example, American scientists Adrian Mellott and Richard Bambach have focused not on impact craters, but on the appearance and disappearance of different life forms in the fossil record. And they've concluded that there is a regularly recurring cycle of extinctions, which they estimate to be every 27 million years, plus or minus 500,000 years. And they find, their conclusion is that there is a greater than 99% probability that this finding is not due to chance, that it really is a regularly recurring thing. In the last decade, these scientists and others have had a vigorous debate over the subject, but as far as I can tell, neither side's managed to convince the other.
It occurs to me that once we return to regularly visiting the moon would also be suffering these impacts on that same schedule, and those impact craters would not degrade.
And Mars and potentially other bodies we may one day get to, although, of course, the gas giants won't be of help.
Yes, right. All right, so what about the idea that some version of the Nemesis theory is true, that the sun does have a distantly orbiting companion?
In this case, the question is what kind of companion the sun has. It obviously isn't a bright star like our sun, or we would have known about it like since always.
Right.
That leaves us with several possibilities. If the sun has a companion, it could be a dim red dwarf. It could be a failed star like a brown dwarf. It could be a huge but unseen planet. And it could be a black hole. So you couldn't see it at all in visible light.
So let's talk about each of those then. What is a red dwarf?
A red dwarf is a star that doesn't weigh very much. The smallest red dwarfs have only 8% the mass of the sun, though the biggest get up to about 60% of the mass of the sun. Because they don't weigh much, red dwarfs aren't heavy enough to do as much fusion as the sun can. They can't crush hydrogen into helium as effectively, and that means they're quite a bit cooler than the sun, with temperatures between about 2,000 and 4,000 degrees Celsius. The sun, by contrast, has a surface temperature of about 6,000 degrees Celsius or 10,000 degrees Fahrenheit. But because red dwarfs don't burn as fast, they last a really long time. Our sun has a lifetime of about 10 billion years before it runs out of nuclear fuel and becomes a white dwarf. But some red dwarfs can last for 10 trillion years before they run out of fuel. So that's 1,000 times longer than our sun. Because they're cooler, red dwarfs throw off more light towards the red end of the spectrum, which is why they're called red dwarfs. And so they're both redder and smaller than the sun, and they aren't as bright. Even the brightest red dwarfs are only 7% as bright as the sun, and many are less than 1% as bright as the sun. That makes them really hard to see. It's thought that as many as 3/4 of the stars in the Milky Way are red dwarfs, but they're so dim you can't see many in the night sky. So when you look up at night, most of the stars you are seeing are not red dwarfs. Even though red dwarfs are all over the place, they're just too dim for your eyes to pick them up when you look at the night sky. And that's what some people think Nemesis is. For example, on his webpage, Richard Muller writes,
Nemesis is most likely a red dwarf star, magnitude between 7 and 12. Virtually all such stars have been cataloged, but very few of them have had their distance measured. It is likely that Nemesis, if it exists, will be visible with binoculars or a small telescope. We don't need a large telescope to find Nemesis. We need a small or medium telescope and enough time to look at and analyze 3,000 candidate stars. A series of images taken throughout the year should allow us to measure the large parallax of this star.
So Nemesis may be a red dwarf, but it also may be a brown dwarf.
So what's a brown dwarf?
It's an object that's even smaller. Brown dwarfs are so small that they're kind of on the border of being between a planet and a star. You know, we mentioned them earlier as a border case. They have as a mass that's between about 13 times that of Jupiter and about 80 times that of Jupiter. They're not big enough to get fusion going in a big way, so they just kind of smolder. They can't burn hydrogen at all, but they can fuse deuterium or lithium in some cases. Because they can't burn hydrogen, they don't shine brightly, and that's why they're called brown dwarfs, though that's something of a misnomer because they wouldn't actually be brown. If you were up close enough to see one with your eyes, they might look orangey red, or they might look magenta, purplish to our eyes. So you could have, if you were near a brown dwarf, it's like, wow, here's this cool purple star planet thing. Needless to say, they're even dimmer than red dwarfs and thus even harder for astronomers to find. And some people think that Nemesis may be a hard-to-find brown dwarf. For example, D.P. Whitmire and A.A. Jackson, who were among the first scientists talking about Nemesis, thought it likely to be a brown dwarf.
What about this idea that Nemesis is a huge but undiscovered planet?
Well, this is less fun to think about than the idea it's a star, because having an extra planet in our solar system is nowhere near as much fun as having an extra star. But it would be possible. This fits with recent theories that there is a big undiscovered planet in the outer solar system that is affecting the orbits of some of the objects in the outer solar system. This planet is proposed to be between 5 and 15 times the size of Earth. And some people have been taking to calling it Planet 9, but that's based on the erroneous idea there are only 8 planets when there are dozens. So really, you should call it the Planet X hypothesis. I should point out that if we find Planet X, it does not mean that the Nemesis hypothesis is true. In order for Planet X to be Nemesis, it would have to have the right mass and be in the right kind of orbit to fling comets or asteroids our way every so often, and that might not be the case. It might have the wrong mass or be in the wrong orbit. My understanding is that the proposed Planet X isn't big enough, that it's only 5 to 15 times the size of Earth. But my understanding is that Nemesis would need to be a gas giant bigger than Jupiter, and Jupiter is like 300 times the size of Earth, but not so big that it becomes a brown dwarf. But there could be both Planet X and Nemesis out there.
All right, finally, what about the idea that Nemesis is a black hole?
This has also been proposed. The black holes that people are most familiar with are, and really the only ones that we currently know for a fact to exist, were originally stars that were so big that when they ran out of nuclear fuel, they blew up as supernovas and then started collapsing. But there was so much mass left over, even after the supernova blew stuff off, that their gravity caused them to keep collapsing to the point that they became so dense that they created a zone where the gravity is so strong that not even light can escape. And that's why they're called black holes, because they don't shine. Exactly what happens in a black hole, we are not sure, and there is a bunch of debate about it. But it may be possible for black holes to form without a star. For example, it may be possible to create micro or quantum black holes with high-energy collisions between particles. When they activated the Large Hadron Collider a number of years ago, some were concerned that it might make micro black holes, but so far we haven't seen any. It also may have been possible in the early universe, shortly after the Big Bang, for there to be regions that were so dense they underwent gravitational collapse even without a star. And these, if they exist, are called primordial black holes because they would have formed right after the beginning of our universe. We talked about them as a possible explanation for dark matter back in episode 83. And since they're formed without stars, they could have any mass, including the right mass to be Nemesis or even Planet X. In fact, in September of 2019, two scientists named Jakob Schultz and James Unwin published a paper arguing that Planet X might be a primordial black hole that got captured by our sun's gravitational field. And that's why astronomers haven't been able to find it yet, because it doesn't shine.
You don't want to run into that when you're out exploring the solar system, that's for sure.
Yeah.
So since Nemesis was first proposed in the 1980s, I imagine astronomers have been looking for it. But what have they found?
Well, as you can guess, they haven't found it yet. After all, if they had, it would be all over the news, and you would have heard about it. I mean, that would apply whether it's a red dwarf, a brown dwarf, a big planet, or a black hole, primordial or otherwise. You would know about it from the news. And astronomers have been looking. In recent years, there have been surveys of the sky using new instruments, and so far they haven't turned up anything like Nemesis, but it's still possible it's out there.
And what alternatives to Nemesis are there if there are regularly recurring mass extinctions, but they aren't due to the sun having a companion on a distant orbit? What could cause them?
Here I can imagine a couple of theories. The first one is that the mass extinctions are due to something here on Earth. Perhaps there's something about the nature of life that just causes a large number of species to die off every 27 million years. But it's hard to think of a natural explanation for what that might be. I mean, maybe the ecosystem gets so crowded every 27 million years that it's effectively overpopulated, so there's a mass die-off. But that wouldn't explain the iridium and rhenium in the extinction layers. And so this seems really unlikely that there's just something about the nature of life or Earth that causes this. That pushes me to the second theory, and according to this one, there is something about the situation of our solar system other than a companion body like Nemesis that causes the extinctions. But if it isn't a star orbiting our sun, what in our galactic environment could it be? The most popular explanation is that it's our solar system's drift above and below the galactic plane. The basic idea is that the sun, as it orbits the center of the galaxy, slowly bobs up and down in the galactic plane. It's like the sun is on a super slow motion roller coaster going up and down as it moves. When the sun is really high up or really low down in that cycle, it's in areas where there's less mass. But when it's in the center of the cycle, it passes through the denser part of the galactic plane where there are more stars and clouds of interstellar gas and dust. The idea is that these stars and clouds and extra mass in this region is enough to disturb the motions of comets and asteroids in the solar system, leading to the extinction event. So we're on a roller coaster of death. The idea is sometimes called the Shiva hypothesis, after the Hindu god of destruction and creation. With each new series of impact events leading to a mass extinction, there follows a new explosion of newly evolving life forms as evolution causes the now empty ecological niches to be filled up with newly evolved creatures, the way mammals had a major spurt of evolution as soon as the dinosaurs were no longer dominant in the environment.
And so what evidence is there for this Shiva hypothesis?
The sun takes about 220 million years to go around the galaxy, and it bobs up and down on about a 26 to 30 million year cycle, which fits the extinction pattern. And there's another argument. Those guys, Mellot and Bambach, who found a really strong extinction cycle for 27 million years plus or minus 500,000 years, they argue that this is too regular a cycle for it to be Nemesis. If there were a single companion star, they argue, then this star would be tugged by neighboring stars in a way that should generate more variability than we see in the cycle. So they argue that the cycle is so regular, it should be caused by something other than Nemesis. And from what I can tell, the Shiva hypothesis, the roller coaster of death idea, is the current most popular theory among people looking at the question.
My theory is that it's aliens shooting asteroids at us every 27 million years because it's always aliens.
It's always aliens. Yeah, I know. I was tempted to mention this when I said I can't think of a natural explanation for what would do this. I was tempted to go to some science fiction scenarios. Yeah.
I think of the Expanse series. So, Jimmy, what's your bottom line on the Nemesis theory?
As a non-expert looking at a complex scientific field, I'm not qualified to have a strong bottom line. However, what I can tell you is that these days it seems most of the experts favor the Shiva hypothesis rather than the Nemesis hypothesis. Both of them are interesting, and both would explain the mass extinctions that have played a crucial role in the history of life on Earth. However, Nemesis is still possible, and we just haven't found Nemesis yet. Personally, I love the idea that our solar system has a second star out there, so part of me is rooting for that.
All right, one final question. If there is a Nemesis that will one day swing near the sun and cause a new rain of death from the sky, like a Michael Bay movie, or even if there's no Nemesis, but there's something causing the periodic extinctions, should we be expecting one to show up in our lifetimes?
No, and not even close. The good news is that Nemesis, if it exists, shouldn't swing around again for another 13 million years. Same thing would be true of the Shiva hypothesis. The next comet storm, put it on your calendar for about 13 million years from now.
Good. I'll clear my calendar. So I'm not sure my calendar goes out that far. All right, Jimmy, what further resources can we offer to the listeners on this theory?
Well, we have Richard Muller's book, Nemesis, the Death Star. We'll have a link to where you can get that. Also, Sam Keen's excellent book, The Disappearing Spoon, which is a really fun read. We'll have a link to Richard Muller's homepage on Nemesis and his most recent paper, which is from 2002 on Nemesis. Also, his 1985 New York Times Magazine article. We'll have Wikipedia on Nemesis, Schultz and Unwin's paper on Planet 9 being a primordial black hole, another story on how our solar system might have a black hole, and finally we'll have that space.com article on multi-star systems that we read from earlier.
All right, so let's talk about mysterious feedback from our listeners. You sending in feedback on our previous shows. But Jimmy, I understand you recently got a piece of physical mail as feedback. What can you tell us about that?
Well, I got an email initially from a lady who said her son, who is, I believe, 8 years old, is a big fan. Yeah, he's 8 years old. His name is Christian. He's a big fan of the show. And he had written me a letter with a picture of a Yeti that he wanted to send me. So I gave her a physical address she could send it to. And we'll have a link. I scanned the letter and put it on my website. So we'll have a link so you can see the letter itself. But Christian here has a letter that he has illustrated, not just with a Yeti, but with other things. And it's from January 15th, 2020. He says, "Hello, Jimmy Akin. I have been listening to your awesome podcasts, but I haven't listened to all of them. I want to listen to the one about the Yeti, from Christian, age 8. And then he has several cartoons. One of them is, it looks kind of angry, but it says Mommy or Momi. And there's also kind of smiley face, and there's something that looks like maybe a flying gargoyle or something that says FEP ? And we have It's Always Aliens. And and also on this side of the page we have a picture of a Yeti, and he's saying bye. And then on the other side of the page we have some illustrations of Planet Zog from Calvin and Hobbes. And there is a speech balloon that says Grop, and another speech balloon that says bye-bye Alv I, or bye-bye Alv Ak. And his mother has put an asterisk by that and explains that it's alien talk.
Of
and
course.
It looks like it may be pronounced BB Av Kak. So this really, I was delighted to get this, and I want to encourage all of the young listeners out there. Happy to hear from anybody, anytime with feedback, and this was especially delightful. So wanted to share that with the audience. And thank you so much, Christian, and Christian's mom, for sending this to me.
I love that our audience includes listeners of all ages. It's so much fun.
Yeah.
So we have some more feedback on our episode on religion, magic, psychic science. Jason A. on Facebook writes, "Another top-notch episode, guys. Informative and interesting. Words mean something, and this dissection of terms, their history, and their use was most helpful. I've gone back to start listening to the archive, starting with episode 1, because your shows are good enough to listen to repeatedly. I appreciate everything and only wish your show were daily instead of weekly."
Well, I that would be a lot of fun, but I don't think I could do the research quick enough for daily.
We need a staff, and for that, we need more patrons. So,
Yes.
Jason T on Facebook writes, "This has to be one of your top 10 best."
Awesome. Thank you. It's certainly a foundational one where we differentiate concepts that are going to be very important for future episodes, because in future episodes, we will be talking about religion, magic, psychic phenomena, and science.
Tammy L on Facebook writes, "I'm glad you addressed wearing things like the miraculous medal, but I wondered about crossing ourselves. I know when I cross myself, this is a reminder of my baptism, and I think in some cases, people may also use this inappropriately in a superstitious way. My question is, does crossing ourselves protect us in some way? I tend to do this sometimes when I hear something blatantly blasphemous or when I'm frightened. Is this wrong for me to do? I'm a convert to Catholicism since 2008, but it's become almost an automatic gesture for me."
It's not automatically superstitious. It could be if you think that just the gesture is going to do something. But if you're doing it as an enacted prayer, asking God to bless you or protect you, then there's nothing wrong with it. And you don't have to think about that actively every single time. Theologians talk about having a virtual intention where you establish at some, you make a choice at some point and say, when I do this action, this is what I mean by it. And even though you may not consciously call that to mind, it's still there in the back of your mind. That intention is still there once you made that choice until you choose differently. So if you decide I'm going to cross myself as an act of prayer, asking God to bless or protect me and put myself in his hands, then go ahead and do it.
All right. Brooke Kennel writes on YouTube, "Fascinating topic. I'm surprised by how often this comes up in my academic life. I would like to ask a question about the definition of magic. I've seen some historians suggest, imply, or state in throwaway comments that the Church/Inquisition persecuted witchcraft in the late medieval, early modern period because it wanted to protect its exclusive claim to its magic, by which they generally mean the sacraments, especially the Eucharist, from challengers. It seems to me that historians who focus on the conquest of the Americas imply similar things about the ecclesial approach to indigenous religion and religious syncretism. If magic cannot be defined by reason alone, and you have to appeal to religious authority, how do we respond to the cynic who thinks that the rites and sacraments of the Church constitute magic? How do you defend against the charge that a priest offering Mass is doing essentially the same thing as a bruja sacrificing a chicken? And how should a Christian respond to the charge many Jewish authorities made that Jesus was simply a magician? My understanding is that miracles were part of his way of demonstrating his authenticity as being sent from God. At any rate, this is something that's been bothering me for some time because I never know how to respond to it when I see it in scholarship."
So for people who haven't gone back and listened to the episode, basically what I proposed was a sociological definition of magic as an unauthorized ritual that is, shady and often of foreign origin, belonging to a different religion. And so what counts as magic for you is going to depend on what religion you are. If it's a ritual that is not authorized by your religion, you could look at it as magic. And that's how we got the term magic, because the Greeks looked at the rituals that Persians were performing, that magi were performing, and said, oh, well, that's that magi stuff. That's magic. So in applying it to this situation, I think that one of the mistakes, there are a couple of things here. One of them is, yes, miracles and supernatural events do provide evidence in favor of religion. And so Jesus' miracles, and especially his resurrection, provide evidence for the Christian faith that you don't have comparable miracles for in other religions. You got lots of miracle claims, but you don't have anything as verifiable and major as the resurrection. There's better evidence for the resurrection. It's not just the claim he came back from the dead. There's evidence for that. But you got to study the evidence to know about it. The other thing is, people today tend to read everything in terms of power politics and self-interest, which is a very cynical, jaded look at things. And so if you take that approach where you've got to explain everything in terms of self-interest and power politics, then you look at, okay, we have these priests who are down on the idea of brujas sacrificing chickens, and it's their way of protecting their own rituals, protecting their own magic. That's unduly cynical. Put yourself in the heads of those priests. Are they just wanting to protect themselves? Or are they sincere believers that if you're sacrificing chickens to unauthorized gods, you're in contact with demons and you're putting yourself in jeopardy and you're putting other people in jeopardy. They're not principally thinking about, oh, we're going to lose our jobs if this gets out of hand. They're thinking these people are endangering their own souls and the souls of others. That's, I think, how historically Christians have looked at these things. After Christianization occurred, there wasn't a danger that, oh, everybody's suddenly going to go over to this other religion and the priests were going to really lose their jobs. That's never been at the forefront of priests' minds. It's always been about the good of souls.
All right. And then this last comment comes on YouTube from a YouTube user called 20,000 Subscribers Without Videos Challenge.
Good luck with that challenge.
So here's the comment. I was told by a priest that magic and or psychic phenomena are at least partly explained by human faculties that were damaged by the fall and would thus be illicit to use.
So it's an interesting claim, but you'd want to back it up. Now, it's possible that with research, we could find that there are human faculties that are responsible for psychic phenomena, let's say, but it's also possible that they're damaged by the fall. But if you want to claim it's therefore improper to use them, you need to provide some kind of evidence for that, because every aspect of human nature has been damaged by the fall, but that doesn't mean you can't use human nature. If you had to stay away from something just because it's been damaged by the fall, you'd have to stay away from human nature, which is impossible. And so I think that the priest had an interesting theory, but you'd have to go further if you wanted to claim that someone should adopt this theory, that it's illicit to use them because of damage by the fall. Why is that the case? I mean, like, name another aspect of human nature that can never be used because it's been damaged by the fall. I can't think of one.
Right. And I can think of some pretty major aspects of human nature that are damaged by the fall pretty prominently that we must use.
Yes.
All right.
Otherwise, the race goes extinct.
Exactly. Jimmy, do you have some mysterious headlines for us this week?
I do, and we have a solar system theme since we were talking about Nemesis. One question, so suppose a rogue star flies through the solar system. Could it kick Earth out of the solar system?
Ooh.
Yeah, the answer is maybe, but probably not. Then secondly, Earth has a new mini-moon for the moment. We have discovered an object that appears to be between 6 and 10 feet across that is currently orbiting us. It appears to be a natural object, although there is some debate about that, and it will eventually leave orbit, but for now we have a second mini-moon.
Great. Now we're no longer a planet.
Yeah, we haven't cleared our orbit. Got to change all those textbooks for the kids. There are only
right.
7 planets in the system now.
So, folks, we want to turn to you and appeal for your feedback on today's episode. We want to hear your theories about the Nemesis Death Star theory, what you think. And you can let us know by going to sqpn.com/mysterious. And leave a comment there, or to the Jimmy Akin's Mysterious World Facebook page. You can send an email to mysterious@sqpn.com or send a tweet to @MYS_world. We can use the hashtag of mysterious feedback. So, Jimmy, what's our next episode going to be about?
Next week, we're getting in the TARDIS and going back 3,200 years to investigate an ancient Egyptian black magic harem conspiracy.
Ooh, all right. So, folks, be sure to come back for that. Meanwhile, if you've enjoyed this podcast, please share it. You have enjoyed this podcast. I'm sure you have. And that's why you want to share it with your friends and write a review of the podcast in Apple Podcasts or wherever you get your podcast from, and help us grow this community of listeners and reach more people with these great subjects we're discussing. You can find links to Jimmy's resources from our discussion and links to the mysterious headlines on our show notes at sqpn.com/mysterious. And remember to help us continue to produce the podcast by visiting sqpn.com/give. Until next time, Jimmy Akin, thank you for exploring with us our mysterious world.
Thanks, Dom.
And once again, I'm Dom Bettinelli. Thank you for listening to Jimmy Akin's Mysterious World on StarQuest.